we have taken any charge, like let's say we have taken it as a positive charge. So when we have taken it as a positive charge, then first we check if the net force on each of them is zero. When we check it, then when we have checked it for this as positive, then we had realized that these two charges are not in equilibrium. So this means this cannot be a positive charge. Then we have taken it as a negative charge by hit and trial method, because positive didn't work for us, so we had taken it as negative. Now when we take it as a negative charge, all the forces cancel each other and we see the system is in equilibrium. So that's how it became a negative charge. It could have been a positive charge if the question would have been different. This would have been minus or something else. So is this clear to you?
Yes, ma'am. Now it's
Okay.
clear.
So if you, I think you will, when you will do the question on your own, because you've just seen this small part of it, so it will get clear. All right. Then we had started with superposition principle. So yes, what was superposition principle? Did anyone of you remember it? Yes, all those who were present.
When a number of charges are interacting, the total force on a given charge is the vector sum of the forces exerted on due to all other charges.
Yes, ma'am. Correct. Perfect answer. See, not only force, it can be any vector quantity. When we apply superposition principle, what happens? What do you do? Simple step of solving n number of charges are there. If there are n number of charges, if there are n number of interacting electric fields, if there are n number of interacting electric force, we have to find the net resultant. So what do? We take the individual charges first. Like if electric field is asked, then we take what is the net electric field on a single charge. We take out the direction of that charge. Then by using simple vector laws, we add them. We don't add them algebraically because all these are vector quantities. These have direction. If a quantity is there which is a scalar quantity, then we can simply add it. So this was superposition principle. I think let's do one more numerical. We had seen this question. And also one more thing. On systems which are symmetrical, like equilateral triangle, pentagon, all the systems which are symmetrical, the net electric field at the center will be zero. Net electric field or net electrostatic force, all these will be zero. So we had seen this question. I think we should do one more question on this topic, then we'll move forward to new topic. So all those who are having doubts in superposition principle, this will get clear. Just try it once yourself also. Charges of plus 5 microcoulomb and okay, let's take 3 charges. And minus 10 microcoulomb. So yes, Khalid, tell me what is this micro? How do we replace this? How do we convert it into an SI unit? Yes, Khalid. Yes, anyone? Anyone else?
You have to multiply into 10 to the power of minus 6.
10 to the power minus 6. Yes, you're also right. And Shravya, correct. 10 to the power minus 6. All right. So in this question, if it is required, then you can convert it also. Otherwise, leave it in this manner only. Because this is not the SI unit of charge. SI unit of charge is only coulombs. So these are placed in air at the corners A, B, C of equilateral triangle. So what is the angle of equilateral triangle? 60 degree. having each side equal to 5 centimeters. You have to determine the resultant force on the charge A. So this is given to you. Corners are given to you. Charges +5, +10 and -10. These are given. So let's say this is A, this is B, this is C. A is +5 microcoulomb. B will be +10 microcoulomb. C will be -10 microcoulomb. These are given to you, and the separation between all the charges will be 5 centimeters. So centimeter is also not the SI unit of length. So convert centimeters also in meters. But before that, just giving you a hint, what you do, you have to calculate the net force on charge A, on this point A. So do one thing, check it for each. You have to apply superposition principle. Now see how will you solve it using superposition principle. What do? We take individual forces first. You have to calculate the net force. So first calculate the force between A and B. See where the force will go, towards B, towards A, along AB, along B, in whichever direction. Then check it for A and C. Is it going towards this, towards C? Is it going towards A? The resultant force when you are considering the force between E and C. Once you have the forces on charge A because of B and C, then apply your parallelogram law and see what is the resultant force. So just copy it down, take 2 minutes, then we'll discuss it together. I think by now you all must have drawn the figure at least and written down the question. So let's discuss it. It will get clear. Your topic of Coulomb's law also will get clear from here only, and superposition principle, application of superposition principle also. So let's discuss this. Okay, on you all only tell me this. Atif, you tell me. What will be the direction of force because of B on A? Will it be along BA or will it be along AB? Towards B or towards A? Atif, you there? You can type also, even if you all want, any one of you. Atif is not here. Yes,
Can you
ma'am.
hear me?
Yes, Atif, yes.
Yeah, it will be along AB.
It will be along AB, means in this direction. Towards, are you saying in this manner? Along AB, Atif?
Yes, teacher.
See, when this is positive plus 5 Coulomb, this is plus 10 Coulomb. B means plus 10 Coulomb will repel plus 5 Coulomb or attract plus 5 Coulomb? Atif?
It will repel.
Repel. So when in using this direction, this is trying to attract it. This is plus 10, this is plus 5. So plus 10 will try to push it away. It will try to repel it because this is a both of these charges are positive. Let's say this is F1. F1 means force generated on A due to B. So the direction will be this only. Yes, Hania. Hania, you tell me, because of C on A, what will happen? Will it be along AC in this manner or CA? This is plus 5 microcoulomb. This is minus 10 microcoulomb.
AC.
AC in this manner?
Yes.
Yes, right. See, because minus 10 microcoulomb will try to attract plus 5 microcoulomb. So this will be the direction. Let's say this force is F2. Huzefa, you tell me what is this angle between these two? This is an equilateral triangle. So we know what is this angle. I'm asking you angle between F1 and F2. Not only Huzefa, all of you. Reply me in the chat box. What is this angle between F1 and F2? No, Shravya, check once again. F1 and F2. Yes, Huzefa, Memuna, right? See, this angle is 60 degree. This is a straight line. Total is 180 degree. 180 degree minus 60 degree. Yes, now it's correct. So it will be 120 degree. So resultant of these two forces, this is F1 force. Now this will get your vectors also revised. This is F2. Two vectors are there making an angle of 120 degree. How do we solve these two vectors? We solve these by using Parallelograms Law. Yes, Atif, now it's correct. Parallelograms Law. So the resultant will be somewhere here. If you complete the parallelogram, resultant is given by the diagonal of the parallelogram. So this will be the resultant force which we have to calculate, means along this direction. Is it clear till here? First tell me. This is your basics of 11th. If anybody wants me to repeat parallelogram law as well, I can do that. Is this clear?
Yes, teacher.
Yes, ma'am.
Okay. So if anyone wants to ask, one can ask. Now see, we just know we now have to just calculate F1 and F2. Now we know the angle also between these two forces. Let us take out the magnitude regarding F1. Okay, let me explain the parallelogram law first. Then we'll put in the magnitude. First, let us revise the 11th part, then we'll come to the 12th standard. See, if two vectors are there which represent the two adjacent sides of a parallelogram. Parallelogram is this. So if two vectors represent these two adjacent sides of parallelogram, then the resultant of these two vectors, this is given by the diagonal, means in this direction. So similarly, in this we had F1 with us. In this we have F2 with us. Both of these are representing same as triangle law. Same as triangle law. It's just that in triangle law we had three sides. Yes, triangle law. All right. In parallelogram law, it is a parallelogram figure. Both the laws are same. The calculation is same for both the laws. Now see, you just have to complete the parallelogram law and the resultant is given through the diagonal. So this is the resultant. So the magnitude of resultant. Yes, Salman will tell. Salman, what is the magnitude of this resultant? We had done this together. How do we write the resultant of two vectors using parallelograms law? Salman? Unmute yourself or write in the chat box. Salman, we are not able to hear you.
Ma'am, he has network issues.
Okay. Fine. All right. So anybody else who remembers parallelograms law?
F1 square plus F2 square plus 2 F1 F2
If the angle between them is theta, then
cos 2 F1 F2 cos theta.
2f1 f2 cos theta, correct. So this is how the resultant of a parallelogram is given. So we have to use this only. This is from your 11th standard vectors. Now see f1 and f2. We have to first check what is f1, let us check what is f2, and let us check theta. So theta we have seen, if that angle was 60 degree because of equilateral triangle, this will be 120 degree. So theta we know, theta will be 120 degrees. Regarding F1, we have to calculate force on F1. So see, according to Coulomb's law, this is given as F Q1 Q2 divided by R square. K is 9 into 10 to the power 9. What is this? Q1 and Q2. What do we take among these Q1 as and Q1, Q2? Minus 10, 10, 5. 10 multiplied by 10, 10 multiplied by 5. Which one? For F1 only. Means force on A because of B. Correct. It will be 10 and 5. This is exerting force on this. This is what our F1 is. So just forget everything. Now you have to apply it individually. How do you calculate Coulomb's law? How do you solve for Coulomb's law? Had there been nothing else, both only these two charges were there, only A and B were there, then how would we have solved it? Simply K, Q1, Q2 divided by R squares. The separation between them is 5 centimeter. So we'll do the same. Rest, superposition principle is your basic vectors only. So Q1 is 10 microcoulomb. So we'll write 10 to the power minus 6. 5 microcoulomb, again 10 to the power minus 6 divided by 5 centimeter square. So this will be 0.05 whole square, means in meter square we have converted. So if you will solve this, 5 will get cancelled. It will be 25. 5 by this will be 180 Newton. So direction of, once solve this after the class or check it tomorrow after the class or right now only. 180 Newton, the direction will be towards BA. This will be towards BA. See how it will be towards. Towards BA means this direction. This is towards BA. Means it is moving in this direction, away from it. Had it been AB, then it would have been in this direction. Then we have to calculate it for F2. K Q1 Q2 divided by R square. All right. So F2 and F1. F2 would be the same. Correct. That's what I was about to ask you. Yes, Shravya, you are right. See, both the charges are same. The separation between the two charges is same. It's just that the sign is different. And we don't consider this sign when we are putting Coulomb's law. We just take out the magnitude of the charges. So F2 will come out to be the same as well. It will be 180 newtons only. See, K will be 9 into 10 to the power 9. Q1 will be 10 into 10 to the power minus 6. This will be 5 into 10 to the power minus 6. Separation between the two charges is still same again, 0.05 square. So this will be 180 newtons. Direction. All of you write me. What is the direction? Towards along AC or along CA? Correct, along AC. This will be along AC. So now we have F1 with us. Now we have F2 with us. We know the angle between these two. So we just have to put in simple parallelogram law. This will be 180 whole square plus 180 whole square plus 2 into 180 into 180 multiplied by cos 120 degree. Okay, what is cos 120 degree?
1 by 2.
1 by 2. Anyone else?
Minus 1 by 2.
Minus 1 by 2. Now it's correct. It is minus 1 by 2. So even if you, let us just write F only, F1 only. Yes, minus 1 by 2. Let us write F1 only for both of them since the magnitude is same. F1 square plus F1 square plus 2 into F1 square means F1 into F1. Cos 120 will be minus half. We'll put 180 back. Let us just write F1 to ease our calculation. So 2 will get cancelled. This will be F1 square plus F1 square minus F1 square. So F1 square gets cancelled. Under root F1 square is F1 only, and the magnitude of the resultant force will then be 180 Newton. It will be. So your resultant force is 180 Newton. Is this clear?
Yes, ma'am.
Yes, ma'am.
Regarding the direction also, let us just revise so that your parallelogram law gets revised once again. Regarding when you take the direction, let's say this resultant makes an angle beta with this force. That's how we take the direction. This is the magnitude we have calculated. If this is F1, this was F2, this was the resultant force Fr, which was also 180 Newton. Let's say this makes an angle beta with it. This hole was 120 degree, that is theta. So see, whenever you have to find this tan beta, and whenever you have to get the direction for parallel, it's just your basics parallelogram. I'm just revising it once, then we'll move forward. So all those who have forgotten it can revise it. Otherwise, till here your answer is fine. So you get as if this is A, this is B, you write it as A sine, or let's reverse it. Let's make it as B and A. If this vector is B, this vector is A. So this is B sine theta divided by A plus B cos theta. So all those who don't remember this formula, this is for the calculation of the direction of any two vectors. So B is the vector with which the angle has been made. So angle has been made with F2. So tan beta will be F2 sine. You have to take theta. Theta was 120 degree. Theta is the angle between the two vectors. So this is 120 degrees divided by A is F1 plus again B is F2. Now cos 120 degrees. So F2 you know as 180 degree. Sine 120 degrees root 3 by 2. F1 is once again 180 degree plus F2 will be 180, cos 120 will be minus half. So minus this will be minus 180. Only this root 3 will be left. See, minus 2, all these will get cancelled. So root 3 will be left. So when your angle is root 3 for tan, beta will be what? When is your angle for tan as root 3? Yes, correct, Shravya. Anybody else? Only Shravya has answered. This is from your 10th standard. When is your tangent of an angle as root 3? Others, Huzefa? Yes, Atif, right? See, Khalid, which you were saying is the reciprocal of it. That is for 1 by root 3. This will be 60 degrees. 60 degrees is correct. Tan 30 will be, beta is 60 degree. Yes, beta is 60 degree. Fine. So this is just a revision also of your parallelograms law and how to apply superposition principle. So if you are provided with electric field, the way we had done it for the previous question, just take out the direction, calculate it for the individual, apply parallelograms law and get the resultant. So just note down this question, then we'll begin with new topic. And if you have any doubts till here, just tell me before moving on to dipole. It should get clear. So question, I think you have written it. Just text me once when you are done. So most of you are done. Shall we move forward? Any doubts? Okay, all right. Let's move ahead then. Let's see dipole. Before dipole moment, let us understand what is meant by monopole. See, monopole means, mono means what? Single. So whenever there's a system which has only a single type of charge, see, we had seen two types of charges exist in nature. One is the positive charges, other one is the negative charges. Only these two charges exist, none other charge exists. And if both of them, number of positive charges is equal to the number of negative charges, then we say that the body is in neutral. The body is neutral. Regarding monopole, monopole means any system that has a single type of charge. Only one type of charge exists. Means it can have either positive charge or it can have a negative charge. So monopoles system, this is system having only one type of charge. Only one type of charge. By one type of charge, I mean it can either have positive or negative charge. For example, the very basic example is proton. Do you ever see a proton having a negative charge? No, because proton is a monopole. Means it has only a single charge, that is the positive charge. Electron also forms your monopole. Electron is only negatively charged elementary particle. You don't see electron having positive charges. It's the vacancy of electrons that create positivity. That's a different issue. But regarding electron only, as an elementary particle, you see only negative charge residing on electron. So electrons, protons, all these particles are monopoles, which have only one type of charge present. Just monopole moment, understand. Moment, whenever this term comes, this signifies net. What is the resultant? So if you say monopole moment, means what is the resultant charges because of the individual charges. Means if I give you moment, whenever you say, you just take out the term in your mind that it means resultant only. So this basically refers to the net charge. If I say there's this system, this is a system, it has plus 2 Coulomb charge, it has minus 2 Coulomb charge. So if I tell you, ask you to calculate monopole moment, you will see what is the net charge. Plus 2 Coulomb minus 2 Coulomb, net charge is 0. So monopole moment of this particular body is 0. So monopole moment means the net charge only. Why? Because we are considering all the charges which are separate. We have to consider all the charges magnitude and then using their sign, whatever is the net. How you, the way you have been calculating how to calculate the net charge on any body. What is new to you all is this dipole system. Just opposite to it. Dipole means a system that is having equal amount of positive charge as well as equal amount of negative charge. So this means net charge on the body will definitely be 0, because if plus q is there, minus q is there, net charge will always be 0. But it's sure that positive charges are also residing and negative charges are also residing in that particular system. Monopole is meant for only a single charge. Monopoles, like in case of magnets, when we'll reach that unit, you will see if you have a bar magnet with you, you cut that bar magnet in between. So what will happen? The part that was having the north, it won't remain the north only. The other end that has been cut, that will develop south polarity. But in case of electric charges, this do not happen. In case of electric charges, if a single positive charge is there, so it can exist. It will keep on existing. It doesn't need any other charge so as to become a positive charge. All right. While taking net charge, there are two different charges. No, that is monopole moment. See, monopole is a single charge only. That you are right. When you are considering monopole moment, whenever you say moment, then you say net charge. So the way you have been calculating net charge on any body, you have to calculate in that manner only. It's just that a name has been given, that monopole moment. When you will see dipole moment, there you will see why are we referring to two charges and only single charge in monopole. Just wait, I think by dipole it should get clear. Moment will have various charges. Moment will have various charges. It's just that the net charge you will be considering. You have to consider the net charge. All right. So dipole will be, it's just the contrary of monopole. It will be a system having equal amount of positive and negative charges with a separation between them at a small separation. For example, if this is plus q, so plus q has been taken, so the other charge will automatically become negative q, minus q, because dipole is only that system which consists of both the signs, positive and negative. If you have two charges, plus q and plus q with you, that doesn't form your dipole. If you have minus q and minus q with you, that doesn't form your dipole. Just understand the basics of dipole in today's class. From next class onwards, when you will be studying electric field, then you have to relate it to dipole. So you should understand how to identify dipole. Only two charges do not form a dipole. Dipole means a system where positive charge is also present and negative charge is also there. So if you have plus q there, then you cannot have plus q once again. You can, if you have minus q, then you won't have minus q again. In that system, if one charge is plus q, other will automatically become minus q. So this is plus q, this is minus q with a separation between them. And in physics, this separation is taken as 2a. 2a means the separation between the two charges. This 2a represents this separation between the two charges. It could have been taken as a only, the way we have taken it for Coulomb's law as r. It could have been. It's just that by convention 2a has been written. Yes, I'll explain you monopole moment once again. Let me just come to dipole moment, then once I'll compare it and it will get much better clear. For example, molecules like HCl, you have H plus with you, you have Cl minus with you, with a separation between them. So this becomes your dipole. HCl is your dipole. Similarly, Na plus is there, Cl minus is there, positive charge is there, negative charge is there. This becomes your dipole. This is another set of dipole. Now see, dipole moment. Yes, it is necessary. This is the condition of a system being dipole, that one has to be positive and negative with equal amount. Had it been plus q and minus 2q, then it wouldn't have made a dipole. It should be plus q and minus q only. This is the exact representation. Two opposite charges, only two opposite charges, equal to opposite charges. This is also a condition. When I've written no, equal amount of positive and negative charges. For example, plus 500 Coulomb if you take, then you have to take minus 500 Coulomb. This pair, this only forms a set of dipole. Let me explain you dipole moment, then we'll compare all these, then your monopole will get clear what is meant by monopole. Electric dipole moment. So basically this gives the strength of the dipole. It is used in physics to calculate the strength of the dipole. By strength of dipole, we mean the magnitude of it. What is the value of this dipole? How to calculate it? So through calculation, this is given as the product of magnitude of any of the charge. Of any of the charges. Any of the charges I have written by, because both of these charges have the same magnitude only. It's just the sign is different. No, one is plus and one is minus. Both are equal. Equal means both have the same magnitude. So that's why you take any of the charges and the separation between them. See what is meant by this line, what I have written over here. Let me draw it again. If this is plus q, this is minus q, this is your dipole with a separation 2a, and 2a is used by convention only. There is no logic why don't we write it as a. It's just that 2a is the separation between two charges. So till here, is it clear? Are you able to identify this is a dipole? Is it clear till here? Then we'll see what is meant by the second line. Clear?
Yes, teacher.
All right. Now see, dipole moment, this is calculated as product of magnitude of any of the charges. So take any of them, plus q minus q, it doesn't matter because you have to take the magnitude, and both the charges are identical. So write whatever the charge is q, then separation between them. What is the separation between these two charges, plus q and minus q?
2a.
2.
2a. So q multiplied by 2a. This is your dipole moment. This is what I've written. Product of magnitude of any of the charge and the separation between them. Now let us see. Now let us all see what is monopole moment and what is the difference between dipole moment. See, monopole you have understood. Monopole is any system that has only a single type of charge. Means electron. Electron is only negatively charged elementary particle. Proton is only a positively charged elementary particle. So these types of systems form monopole. But if you have a single electron with you and you have a proton with you, this is electron and this is a proton, both have the same value. If you remember, 1.6 into 10 to the power minus 19 coulombs. So both are having the same magnitude. Both of them have the opposite charge. So if a single electron and a single proton is kept, now this forms the dipole. So is the difference, first tell me, clear between monopole and dipole? Will you be able to identify what is a monopole and what is a dipole? Is it clear till here?
Yes, teacher.
All right. Now see what is meant by monopole moment. Whenever this term moment comes in, this gives us the strength, whatever is the strength of the system. In monopole moment, what do we do? Since monopole is a property of a single charge only, means if it's an electron, or let's say if it had it been plus 2 coulomb, this is a monopole having only positive charge. Minus 2, again this is a monopole. Both of these two charges simultaneously, these are forming a dipole. Why? Because 2 magnitude is same, plus minus signs are different, so this forms a dipole. But when we were considering only plus 2 coulomb, when we considered only minus 2 coulomb, it became a dipole. Now see, let me just change the example, because here this is forming dipole already. Now see, when you have to calculate the monopole moment. So if I say plus 2 Coulomb exists, plus 3 Coulomb exists, this is a monopole, this is a monopole. Whenever I have to and both of these are present in a system, so it is not forming a dipole. Now I have to calculate the monopole moment, because dipole moment I won't be able to calculate. Why I won't be able to calculate the dipole moment? Because it is not forming the dipoles. How will I be able to calculate the dipole moment? Monopole moment, it means simply whatever is the net charge present on the body. If it is plus 2 Coulomb plus 3 Coulomb, so net charge will be plus 2 Coulomb plus 3 Coulomb plus 5 Coulomb. Plus 5 Coulomb is the property of the system. See, the whole system is now having a single charge, that is plus 5 Coulomb. So isn't it a monopole now? Plus 5 Coulomb is only there. Initially it was plus 2 Coulomb plus 3 Coulomb, which was present in a system. Both of these are together now. So the whole system is now having a single charge, that is plus 5 Coulomb. So that's why we say it is a monopole moment, because we have a single charge present for the whole system. Regarding a dipole, it's just the difference comes that both of these charges have the same magnitude. Means if it is plus Coulomb, means it is plus minus q, or it is plus q. This forms a dipole. This is a specific case. Take another quantity, take plus q and minus 2q. Then whatever resultant will be, it will be the monopole moment only. Monopole moment only means whatever is the net charge. Net charge means your monopole moment. Is the difference between dipole moment and monopole moment clear? Or should I repeat it once more?
Clear, teacher.
Clear? Now see one more thing. This dipole moment, this is a vector quantity. So you have to consider all your parallelogram law and all your vector additions whenever you are considering dipole. It is not a scalar quantity, it is a vector quantity. So if it's a vector quantity, magnitude you can easily calculate from this formula, q into 2a. Never double this. If I say the charges are separated by 3 centimeters, so don't think that 2a is there, so you will write 6 centimeters. 2a means the separation between them, means 2a is automatically given to you as 3 centimeters. So just keep this in mind. Don't double it. All right. Just take whatever is the separation between the two charges. You are not concerned with whether it is 2a, 3a, 4a. Just consider whatever is the separation. It's just that by convention, this formula has been driven out. 2a is written. Okay, it's direction. This is from negative to positive. Opposite what is the dipole moment in your chemistry. In chemistry, it is towards the electronegative atom. In physics, the direction is from the negative to the positive charge.
To the electropositive.
To the electropositive. In chemistry, it is opposite. So remember, in chemistry, don't just write this. Whenever you're calculating dipole moment in chemistry, it is towards the electronegative element. And one more thing, SI unit. So yes, SI unit is not a tough thing. All of you respond me. Everyone should respond here. Charge, you know, the distance, you know. What should be the SI unit? Nobody will reply by unmuting. Just write me in the chat box. Everyone. This is a very easy question.
You're going to repeat the question.
Question is, what is the SI unit of dipole moment? Formula is charge multiplied by the distance between the charges. You know the SI unit of charge. You know the SI unit of the distance. So what should be the SI unit of dipole moment? Atif is right. Shravya is right. All of you should respond. Only Atif and Shravya have answered. Memuna, yes, correct, Memuna. Thania, respond. Charge, you know the SI unit. You have studied what is the SI unit of charge. You know the SI unit of distance. Yes, Hania, correct. Huzefa, Khalid, Salman, if your network is fine, if you're able to hear, just try to answer this. Okay, Salman, just write me over here. Charge, you know the SI unit, distance, you know. Just multiply both of them. What is AS? Khalid, I think something is missing. Yes, now it's correct. See, SI unit for charge, this is coulombs. So for charge, we have written as coulomb multiplied by the separation between them. SI unit of distance is meter. So SI unit for this becomes dipole moment becomes coulomb meter. Is this clear now? Yes, Salman, right. Coulomb meter. Coulomb for charge and meter. So SI unit for dipole moment is coulomb meter, and it is a vector quantity whose direction is given from the negative element towards the positive charge. Just note down this once. For monopoles, it can be any charge, Shravya. It is not necessary for having the same charge only. The condition is valid only for dipole moment. For dipole, you should have the same magnitude with opposite sign and two charges only. That forms your dipole. Not a charge less than 2, not a charge more than 2. For monopole, you can have any number of charges because single charges will be contributing.
Ma'am, could you scroll up? Done. Ma'am.
Just let me know when you all are done. So for Monday's class, just revise dipole. We'll continue from here only. So all those who have written it down can leave it. Can leave the class. All right, fine.
Ma'am.
Okay.
Thank you, teacher.
All right.
Thank you, ma'am.
Thank you. Yes.
Okay. Allah Hafiz.